Okay, so I've just finished off the day 10. I hope you've looked at that. Okay, let me quickly explain it. Basically 0 is the starting point and we just want to find a path that goes up to 9. You can't repeat the no from a single point. How many different like 9s can you visit? That's basically all we're trying to do. You can read the problem for yourself. I've had enough, so let me just quickly explain my solution, and then we can go through it. So here I just create a list of all the starting points. So basically everywhere, let me zoom in. Yeah, so yeah, I create the starting point list of starting points. So basically everywhere there is a 0. Then I'll loop through those starting points and traverse through, so like move ahead as needed. I pass in the visited highest point as a pointer. So what it does is this basically records every time we reach a 9, so that we don't count that 9 again if we visit it from somewhere else. So it just so as the question mentioned, you can only visit one highest point from a location. So that is why I have the visited highest point right here. And then I pass in the starting point, the value at current position, the size of our map, the actual map, so the data, as I said, the visited highest point. So the traverse function itself is a recursive algorithm. So it'll firstly create total paths, start with 0. If we do, this is our break condition, right? So if we do reach a 9, that means we have completed a path, but we also want to add that 9, the highest point, to our visited highest points, so that if we have a branch, so let's in an example I think we had, so we come down 0 1 2 3 4, but then 3, let's say 3, and there's 4 on the left and the right, so we kind of have to explore both sides, right? If both of those sides reach to the same highest point, then we don't want to add it twice. So that is what this second if statement does by adding a visited point. So we don't count it as twice, and then we return 1 because it is a complete path. Otherwise we'll return 0 because it is not completed if we're counting it again, and then it's not visited. Everything else is, so this is our starting or current row, an index, and the value at this current point. This is all the locations where we will be if we move left, right, or up or down. So column indexing, and this is the main recursive point. I check if the position we're meant to move up or down or left or right is actually inside the map firstly, and we also have to check that one up, what was this function? Yeah, so we're just trying to check the position we're trying to move to next is only one up from where we are currently. So because you need a gradual increase, so we want to go 0 1 2 3 4 5 and not 0 1 2 5 6 7 8, right? So that's what the what's it called, check one up does. And then we will add the return. The return will be, as you know, up here to our total paths. So this is where, like, if we have multiple paths, it will just split like a branch and then just move along those paths. And then at the very end, once we have done all of that, we return the total paths. And then once we have the total paths, we will so for a given point we will have found the total paths, but then we need to also add it for other points. So we set our visited highest points to null, like empty, because for a different starting point we haven't actually visited that highest point, right? And then I just print out the total, and for my answer it was 789 for the input, and I think 36 was the example that they gave. So just a quick explanation for today. Yeah, I think moving forward as well, I might not do too much recordings of me coding while I'm doing it, because I feel like that makes it go longer, you know. But I spent too much time today anyway, so I'll see you, well, I might see you tomorrow again.